So yesterday we have seen few things about monolithic and microservice architecture, and as well as the introduction to API, and as well as why distributed systems are coming to picture, and as well as the uses of microservice architecture. We have seen all these things in the yesterday class, and in the today class we are going to cover about few more things about API with different type of architectures. And before going into the pure technical things of the second session, we better try to clear the confusions of few terms here. So here first is the API versus microservice. So if you can search versus API versus microservice, we have been seeing many things over internet floating about API and microservice. People are using these words interchangeably whenever required. So we will see what actually the microservice and what actually the API here. So to avoid confusion, we can see the examples of them and as well as the definitions, how they work actually. So here I could say microservice, it is more about architecture rather than the implementation of a system. And while API focuses more on how to expose microservices. So these two things work together but not same. As I said yesterday, microservice is a sub-service of our whole system, can be developed and tested and deployed as a sub-service, and can be exposed with APIs to connect with the existing system. So that is nothing but the microservice. Whereas APIs, these are the programming interfaces which are tries to expose the functionality of the developed microservice, that is a sub-service of the whole system, to the user. So let's try to understand it practically. So I hope you people are able to see my mind map here. So here is our website, QAFox website. So here we will be having few things which we are providing as a services. So here is the contact, searching section, trainings, blog posting, and API testing, security testing, automation testing, testing and user login. So we have following things. So as I said earlier, there is a monolithic application. So let's consider our QAFox site with all these things as a monolithic. It's fine. It's a system which contains all the things together developed as a monolithic system. So now we are going to add a new feature. Now we are going to add a new feature like SMS sending to the mobile. Let's consider there is a session tomorrow and we have to send SMS to the enrolled candidates through our website. So this is the feature that we are going to develop as a separate component, as a separate component or the sub-service to our whole application, which includes all these features earlier. So this is the monolithic system. For this monolithic system, we are going to add a new component, that is a sub-service, as sending SMS to the mobile or to the enrolled candidates about the events happening in our system. So this is a simple feature. So in this, we should add event specific details and registered mobiles to be gathered, and we have to add one vendor to send the SMS. So these are the sub things of this service. But this is a simple service. This needs to be developed, tested, and can be added to our system. So the whole thing we consider as a microservice. This microservice provides a service to our system to send SMS whenever the event occurred in our QAFox system. Where? So this is the whole thing is a microservice. But where is the APIs? APIs is, so this line which is connecting to the QAFox means QAFox is able to get the services of this particular feature using this programming interface called API. So this particular microservice component exposes one API saying that, so you call to my API, so saying to send this particular message, suppose, hi everyone, so there will be a session tomorrow at the mentioned time regarding these topics by the presenter name Vishwak. So like that, we will be sending one SMS to a particular endpoint provided by this microservice. So that is, we are using, as a QAFox system, we are using the services provided by the microservice using one interface that we called as a API. Not only this API, so this SMS microservice internally triggers events whenever the specific event occurs. Means this particular part of the microservice needs the details of the events presented by our system. So in order to get the events, there will be another interface which needs to be served to this particular component of the microservice. So here in between event specific things and as well as this particular component, there is an interface, so that is also called as a API. So in between the each component of the microservice and as well as the microservice with the system, there will be a programming interfaces which are connected, we call as a API. So this is the difference, a minute difference. So this is a very minute difference. That's why people are interchangeably use microservices and API. So that's why we usually listening to RESTful microservice or RESTful API, SOAP API, SOAP microservice. So I hope you people understood the minute difference between the API and the microservice. So let's go to the slides again. So here is the difference between API versus microservice. Then we will go to the next thing is the microservice versus web service. So before going into the next thing, so there are other things with the microservice and API. So one thing the microservice is, microservice are mainly used to expose its services using the API, and microservice, as I said, microservice are the small components of the large system and may or may not expose its services using the API. And APIs are the interfaces for the microservices to expose their functionality to the other services. So that's all with the API and microservice. And let's go to microservice versus web service. So this is much more confused topic, and these two things are very much similar, and we couldn't even find a minute difference between these two things. But let's try to understand how the things are going and how we can understand these two things to avoid the confusion. So as a definition, we can see here, web service, it is a way to expose functionality of an application to the other using API over web using HTTP. So it is seems like a microservice, means here we are also using API, and here we are also exposing our functionality of the service, and here we are also using HTTP. Where microservice, it breaks large software applications into loosely coupled modules in which each subservice communicate through API. So here, as I already said about the microservice, so it is a sub small component which will be developed and tested, deployed into the whole system, and can serve a particular feature, a particular functionality. Where the web service is the functionality which will be exposed over the web, whereas microservice is internal to our system, So let's understand this thing as well with our example here. So with all these features, QAFox is a monolithic. I'm adding a microservice component here. So this microservice provided services to our already built monolithic system, and then we are going to the other thing. So here is migrating to new database. Suppose we have all these features, and all these features may have data. Suppose contact information will be saved into DB, and as soon as you go to this particular page, you will be popped up with the contact details. And if you can take any of the things, so training, blog posting, API, so everything has some data. So that data will come from some database, where what I am doing here is I am trying to do I'm trying to connect with a new database instead of the existing database that we are using for our system. So this is the new feature or new kind of migration or integration to the other database. So this is one service that we are going to add to our system. Suppose let's consider this is one service that we need as a separate feature. So in that case, what we will do is we will build one web service. This web service serves the purpose to connect all our features. These are the same features that listed here. So to connect all our features to the new database. So this web service provides the functionality to provide the services to all these features to save its data into the new database. So here the web service providing its a specific functionality over web to use all these features to save its data to the database. So this web service serves that purpose to save the data into database, where this same thing can happen with a microservice as well. But what happens is, if we are going to use the microservice here instead of the web service. All these features are developed in a single programming language. Okay, so in that case we can use the microservice itself. So microservice, suppose let's consider all these features developed using the Java itself, and we are also writing that microservice component here instead of the web service. Suppose let's write here itself microservice. So itself built with the Java itself, and then serving the same purpose as like the web service and providing the data coming from all these pages to the new database. So this is fine, it will work. But the thing is, so recently we have developed one microservice. We may not know whether this microservice is developed using the Java or some other language. So in that case, microservice won't work in this. So in this case, we have to use absolutely the web service, where this web service is independent of the devices that we are using, either it is a web Windows or the Linux or any other system, and as well as the components which are going to connect with this web service, or the functionality that this web service is providing to the other features. Maybe it is independent of the language that particular components develop. Suppose let's consider this particular microservice is developed using some other language like PHP, but all other things were developed using the Java. But this providing the services to our system, and all these features also providing the services to our system. So hence, in order to get the data from all the features and stored into the new database, we require the web service instead of the microservice. Where? So this is the minor difference between the microservice and the web service. So any questions so far understanding the microservice versus web service? So web service mainly is the independent of the device and as well as the independent of the language that we are using, which provides the services to all over the features or all over the other services over the web itself using the web service. So as the name itself suggesting that web plus service means it is providing its services over web publicly, whereas microservice can be restricted to the internal system, and it may or may not provides the access publicly to the other services. It depends upon the functionality that we want in our system or the other system if they want to use. But here the web service, it is compulsory to use, or it is compulsory to publish publicly using the HTTP over the web. So I hope everyone is clear with the both API versus microservice and microservice with web service. Yeah. Let's go to our presentation, and here there is another confusion, that is web service versus client server architecture. So again, these are very much similar, and try to understand how they are differentiating each other. Okay, so web services and client. So before going into this topic, there are few things which are related to web service itself. So as I said the definition, and I said the difference between these two things, whereas we will try to explore a few things about the web service here. So the examples of web service here is the RESTful web service and the SOAP web service. And microservice, here is the example is again the RESTful microservice. So here is which is internal to our application, and whereas the in case of web service it will be publicly published using the HTTP over the web. So web service divided into two things as a RESTful and the SOAP web service, but SOAP came first into the technology. Hence, we mostly refer SOAP as a web service, and later on RESTful as also called as a RESTful web service, where in the SOAP web service we use XML as a interfacing language between the two systems, um, and we use some SOAP protocol to expose its functionality over HTTP. Whereas in the REST, we will use XML, JSON, or some raw text, or some kind of any other kind of data as an interface in the RESTful web service, and we can publicly use these services as well using the RESTful web service. So those are the few points about the microservice and as well as the web service. Let's go to the third difference, third confusion, that is web service versus client server architecture. So as we can see the definitions here, web services.
Vishwa, we have a question over chat.
Okay.
So Radhika is asking like, so the SOAP uses only XML? Is the question.
Sorry, I didn't get you. Once again, I'll be seeing the chart itself.
Okay.
Vishwak, the question I have is, what is the SOAP has to do with XML? I'm trying to understand. I'm very new to this concept.
Yeah, I just saw the question. Fine. So XML is the language, so which is an interfacing language between the systems. Let's consider our web service. As I said, our QAFox website is integrating with a new database, right? So I have taken an example, right? So in that, so I'm using a web service where this web service provides the functionality. So web service developed and exposes its functionality over web. So in order to access its services, we need to use XML language and provide the required information that we require, and then we will get the response from the other end of the web service. Here XML is used to parse our information and sends that information to the server of the web service, where server also responds with some response required with that request that we raised through our web service, and parse that into XML and sends that XML to us, I mean to the user. So here XML is a communication language in the SOAP web service. Okay.
Oh, so web service is a Also, there are different types of web services, and SOAP is one of the
Yeah,
types.
yes,
Yes.
yes. So in that we only use the XML, whereas in the RESTful web service we can use other things like XML, JSON formats, and other raw text format, or some encoded formats we can use in the other RESTful web services.
Okay, got it. Thank you.
Yeah. So I think I can go to the other confusion. So that is web service and client server architecture. So here is the web service. As you can see the definition, these are all about client server communication. Whereas client and server system is a system which includes client and server with and the series of transaction between them. I think there is a typo here. Sorry. So here is a system which includes client and server with a series of transactions between them. So far we have been seeing the few terms: microservice, API, web service, right? So here what I am doing is we are building one feature and exposing its functionality to other system. What happening here is we are exposing means someone is using, and we are exposing means we have something to provide to the other system. So we have one system and the other people have other system. So these two systems named as client and server simply. So uh, a a system which is requesting something or requesting some feature from our service is nothing but a client. I think I have said these definitions in the yesterday class itself. That is client server. Client as a web browser and the server is a web server. That as soon as we navigate through the Google, we got the response as HTML, and our web browser client converted that HTML page into human readable Google page. So the same works here. So the client is requesting for some feature from our service, and we are providing some response as per the request made by the client system to the client itself as per the request as a response. So here we also have one system which provides the response, that is nothing but the server here. So if we can take anything, suppose microservice is a small subcomponent which provides the service, means which also has the system which provides a response to the client, means which includes both client and service. Whereas API is which is used to expose the functionality of microservice, where API connects both client and the server to transfer information between the client and the server. So, and the next go to the web service. Web service is the kind of service which provides the functionality to um, uh, the public using the web. Means here we can, as I said, we can use the HTTP, where HTTP is the protocol. If you navigate to the particular URL or you request for that functionality in the web service, it gives the response to our client system or the web browser. Here also there is a two component system, that is client and the server. So that's why I'm saying these are all about the client server communication. Whereas client and server is nothing but simply a system or the architecture which includes two things, that are client and server. There are series of transactions. Transaction means a request and the response. That series of request and response are going from one system to the other system, that we call as a client server architecture. The other words that I have used, microservice, API, web service, all these work for or work like a client server architecture. So these are the differences between these terms, and let's try to go deep into the client server architecture in the coming slides, how they work, how they came into picture, how actually that client server architecture suits to all application over the world. So let's see all these things in the coming slides. So here, more about client and server architecture. So as we can see the same definition, that is client requests the services from the server and the server processes the request and returns the result to the client. So here the additional comment here, many clients request and receives the services from the centralized server. So don't panic about the technical words. It is such simple as a Google. So suppose I am requesting something from the Google, and some other people also requesting something from the Google itself. So in the same way, in the same time, if any request coming from the any number of clients outside, Google is able to provide its services to the particular user. Here is Google is using a centralized server to provide the services to the requests coming from the many number of people all over the world. Such simple this sentence is. Okay, so we can see few characteristics of client side system or the client in the client server architecture. So here is, we can see some bullet points under this. Before getting into the pure characteristics of the client, we can see the examples here. Web browser. So as I said yesterday itself about the example and as well as explaining the simple thing using the Google. So I mentioned web browser as a client there. So client is requesting something. Here is the email client. Email client which we provide in the Outlook or in the Gmail kind of thing. So which also act as a client, where as soon as you connect to the internet, all the pending or all the requests or the mails coming from the server can be collected and shown in our inbox, and as well as online chat lines. So many are the clients are there in the web technology, whereas we can simply remember that a client which requests something from the service, so that we can call as a client. So here we can see the characteristics. The first is it is the first active, that is master. So the system is already exists. As soon as you connect to the internet, client must active first and request something from the server, which is any pending items which are already there needs to be collected from the server. Means the master is the client which is the first person to ask something from the server, whereas always initiates requests to the servers as always. So client work is to get the information from the service whichever required, whenever required, as per the client request coming from the user interface, and waits and receives replies. Yes, so server may bombarding with huge number of requests. In that case also, client makes a request and wait for the response and receives the whole response. So in order to understand this, we can take like a results. Suppose we have a competitive exam that we have written, and then we are waiting for a results, where the results date came. So we are searching with our ID to get our result of that particular examination. In that case, we enter our ID in the search box and hit enter. So it takes a lot of time, but it gives the response at the end. Okay, so here is, if we are requesting to get our details to the server, saying that this is my ID, please get the details, like that. So if you, as soon as you enter it, the request go to the server. So whenever your request is picked by the server sends response requested, and then sends that response to our client. And Next is the usually connects to a small number of servers at one time. So client, it depends on our functionality or our system. It may or may not connect to the multiple system. It depends on the functionality that we build, and usually interacts with end users using any user interface such as graphical interface. This is such simple. So as I said, web browser is an example here. uh, End user means we. So we are using web browser, and web browser itself the client means, so it is connected with the end user and as well as with the server. So it is the medium between two things. So these are the few characteristics of the client. So these are the general characteristics, but in case of the real system, we need some other characteristics like scalability, availability, agility. So all these things needs to be keep in mind while developing or while using our client in our systems. So let's go to the server architecture. Sorry, server characteristics. So here, server examples are web servers, database servers, email servers, FTP servers, etc. It depends on our system. So whether our system built as a server or the client, or we include both the things together to work like that. So web server means we can say the Google server itself as a server which provides the services, database servers, and the email servers. So like that, there are many servers there in the outside world. So let's get into the characteristics here. It is a slave and waits for the client's query to respond. Yeah. So obviously the master is the client which requests something from the server, means server is a slave. Um, server responds as per the request made by the master, that is client. Next is, it is always listening and ready to respond. So as always. So it works in the way that the client requested for. And server may communicate with other server in order to serve a client request. So here, in a yesterday class, I mentioned Amazon. In the Amazon, if we make one, if you want to buy one item, we it internally calls 8 API calls. Means it is connecting with the 8 different services and get the information and showing us in the in Amazon user interface, that is in the website. So the same is happened here. If suppose we entered our ID in our system, so ID is to get the details from the server, but we entered our ID in the client. Client uses some application. So this some application may or may not contain the details which are required for your ID. But your application, what it will do is, it takes your data as an ID and sends that ID to the some other server to get the details and show the details to you. So this thing happened. So that is nothing but a server may communicate with other service in order to serve a client request. And the next is, server may request client if any additional information provide to process the data. So whenever required, it requests for the client as well by showing some status codes like 403 or 401 or different kind of status codes. We will discuss about those things later. But for now, try to understand, whenever server is unable to process the response as per the request, or it requires as additional information, then it responds with the same content saying that, hey client, I need some more information to process your request. And next is, end users typically do not interact with server but use a client. Yes, obviously. So we use only the clients and we make the request and we get the response from the server. We don't know from where we are actually getting the response, and we are actually able to see that response in the client. The next is server is generally capable of serving multiple clients simultaneously. It is obvious. So which should serve the same purpose in every functionality. So we are not building a server or the system to serve for only one user. It should serve for many users all over the world. So this is few uh, these are the few things about the client and server architecture and its characteristics here, and why this architecture came into picture. We can see here. So these are the four contents. These are the main high level contents here. Why the architecture, I mean this kind of architecture came into picture. So here is the increased productivity. I think you don't need to read each and every line here. I'll try to explain each and every high level things to understand why this architecture came into picture. Here is the increased productivity. So in the early 90s, we only having few services or the few companies which providing the services to all over the world. So whereas there is a request count is also low, and the internet facility to the users is also less, and there are no distributed system, and there are no different devices that people are using. So there is no multi request handling server is required. So in that case we couldn't need this kind of architecture. But nowadays we are using many devices, many distributed system in our fingertips. We were able to request for many things for the centralized servers. So in that case, we require a server to be built to handle multiple or millions requests to serve the response in a fraction of seconds. So in that case, we need this kind of architecture to be built to support this kind of distributed system. So that's why it is came into picture. As you can see, increased productivity and need of using multiple servers and clients have increased due to increased competition. Competition means between the companies like IBM, AT&T, or some Amazon, some Flipkart, some services. Wherever or which market you take, there will be their competition. So in order to serve that increased competition and as well as globalization, we need this kind of architecture. Not only that, to produce the superior quality of products. So there is, we already suppose let's take an example of Flipkart or the Amazon, anything. So if you have an existing system which is no way we are updating or upgrading to the other system or the other features or the other kind of user interface, then it will be hard to look to the new users. Then we may not reach the huge audience to our system. So in order to get that things happen, we need to upgrade to the systems which provides the flexibility or feasibility to the users. In order to build our product to support or to reach the technology or the human minds or the needs or age of the human needs, we need things to be built in the client and server architecture model. And the next is being responsive to the business needs. So there is an issue. Suppose let's consider there is an issue with the system. Suppose our system is monolith, which is not trending, or the it's the old type of architecture. So in that we have built our system. There is an issue. So there is a lines of code is there. We were not able to find the issue. So if it is the customer facing issue, this will be the high priority issue. In that case, if you are not able to fix it in a fraction of seconds or in hours, then it will impact a lot the business. So in that case also, if we are following the latest technology, then it will be very useful to fix and provide the innovative or creative services or the new features to the users. Next is focus on core business activities. Let's consider Amazon. Amazon is not only providing its services to the to directly to the user, but also providing the services to the other companies. That is we call as outsourcing. So Amazon as a company has to work on their core functionality or their core business activities to improve themselves in the market, while comparing with outsourcing. Outsourcing is a they give less priority to the outsourcing. So in this kind of things to be happen means, so in order to get this kind of things to be happen in our system, we need to go for the client server architecture. So here some are characteristics mentioned. Client server technology gives cost effective, logical, consistent architecture model for networking. It also simplifies network interactions. So this provides that flexibility whenever our system is supposed to build with this kind of architecture. So let's try to understand the types of architectures here. So this is as simple like uh, like the client server architecture is. So here I mentioned software architecture consists of few architecture. Following are the famous among them. So here I presented two images. So this is one architecture and this is the other architecture that we name here as the 2-tier architecture and 3-tier architecture. So before understanding this one, so why do we need these architectures came into picture. So here depends on the system that we work with and depends on the performance that we need for our system to perform with end users. We need these kind of architectures. So I'm presenting only 2-tier and 3-tier architecture, but there are other architecture like 1-tier architecture, 2-tier architecture, 3-tier architecture, and n-tier architecture. So let's briefly discuss about the 1-tier architecture. 1-tier architecture. So before going into the architecture types, let's understand what are the types which are included in the whole system. So basically there are 3 layers which are included in the whole system. That is a client layer, data layer, and application or business layer. Whereas client is our web browser which is performing some action, that is one layer. And the data layer is the database layer where it is storing or manipulating data, whereas the business or application layer where our actual logic happens. Suppose if I requested my service to add 2 variables, whereas I'm providing 2 variables to our client, that is web browser. 2 variables is processed and then adds those 2 things in the application layer, where application layer contains that addition logic, and then it saves the data into the database, and database also sends the response to the application layer. From that we will be getting the response back. So these 3 layers are the part of every client server architecture system. So let's get into the types of architecture. First is the 1-tier architecture, as I did not mention here. So 1-tier architecture is a kind where the system includes all the layers as a one component. We can consider as a monolithic system. In that all the components are included in a single container, where the application layer lies, data layer lies, and the client layer lies. So that is a single tier architecture. Whereas the 2-tier architecture, it includes 2 things, client tier and the data tier. So you can see the image here. Here is the client, this is the presentation. So presenting your services to the user, that is a web browser. Here is the server. So this is the database server which provides services regarding the database, which process the requests and which process or modifies the data or stores the data kind of. So So which includes only two things. That's why we call as a two-tier architecture. So don't confuse between the layers and the tier words here. Tier and layer are interchangeably used, which are same. So we can call as a client layer or the tier, data layer or the tier. It's fine. So in the two-tier architecture, client tier itself having the presentation and the application layer, whereas the data tier contains the uh, database related things to happen. In case of three-tier architecture, here each thing is a separate layer in the service. One is the client and the other is the application server, which includes application logic, which serves the purpose, and as well as the server layer. So as you can see, the LAN and the WAN are the examples of these two architectures. So these are such simple to understand. And let's go into the entire architecture. So entire architecture may include the more number of application servers or more number of clients or more number of servers which needs to be included. I mean, two or more. So in that case, we call that as an entire architecture. But most probably, many of the systems who include or who built using the either two-tier or the three-tier architecture. So this is all about the client server architecture. So far we have learned that what is client server architecture, how it is differentiated from the other service, and what are the characteristics of the components like client and the server, and the why that client server architecture came into picture, and as well as the types of architectures here. That's all for today. I'm done with the session. If you have any question, you can ask directly or pose your questions in the chat itself.
So Vishwak, I have one question.
Yeah.
You were mentioning about client two-tier architecture and three-tier architecture, right?
Yes.
So you are giving some example as LAN and WAN.
Yes.
LAN example for the two-tier and WAN example for the three-tier. So what actually this LAN is, and how can that we can relate that LAN to the two-tier, and then what actually this WAN is, and how can we relate that to the three-tier?
So LAN is nothing but the local area network where client and server are internal to the local systems, whereas here is wide area network where the logic of that particular system outside to the local system or the end users. Hence, the application server or the application logic is separated from the whole network. So that's why I'm considering these two things are the examples for the architectures.
Okay. So Vishwak, Nikhil has pinged over chat. He has a question. Could you please look into that?
Yeah, I'm seeing there are huge list of questions. It's fine. Difference between front-end validation, which has UI, and API testing. So this is much more technical. We can discuss in the coming sessions. Anyhow, I will try to say one, try to explain in a few words. That is, difference is you can directly see the response over the UI. That is very much easier to validate the responses in UI, whereas in API you do not have any user interface to the response and to validate something as per your request. So that may not happen in the API. So API only works with response and the request, which is no way showing in the user interface. You cannot see the data in a structured manner like in a UI. So this is the very basic difference between them. So you can get more information in the coming sessions. And as I can say, why API testing came into picture, where we are actually, I mean, after unit test or after the acceptance test or after the integration, where actually we are doing the API test in the test cycle, and as well as why, how important API testing is, and how it is differentiated from the UI testing, how it is difficult to do API testing rather compare with the UI. We can see all these things in the coming session. And the next is, in a Scrum methodology, do we start API testing right from the sprint one, or when to start API testing exactly? So this is um, more like technical towards our testing terminologies. It's fine. It depends on the SDLC process that we are using. While coming to the Scrum, as always in the Scrum, it is the initial, I mean, initial development we are going to start testing in the Scrum. So as soon as you start developing, there will be the requirements, and after that, once one or two APIs has been exposed, then the testing will be started, and then it gets merged into the master system or the master repository, and then we will do some sanity checks or some kind of regression test with the existing system, and then we can deploy. So in the Scrum, everything is with the every small development or small feature development goes into the strict timeline, that is 1 week or 2 weeks. It depends upon the company terms and conditions. But the testing which we will start parallelly with the development, as we can say in the real time. We, as soon as the API is done, we will going to um, test it. So that thing will happen in the Scrum. And the next,
Sure. One thing here, like coming to the first or second kind of thing, like in the sprints, right?
yeah,
So I saw something like this, like APIs will be tested first before actually going for the UI, like because they are ready by the time the UI is all actually ready, right?
yeah, that is what, see, it is serving the purpose to the request, and it obviously shows that response to the UI. So before obviously going to the development of UI, we need to test. So it is, I can say, the after the unit test, we have to do this kind of API testing.
And also it will continue, and also it will continue in parallel with the UI also.
Yeah, yes,
Even
yes.
after the UI is ready, the still
Yeah, we
to
need to do.
continue the API testing in the sprint.
Yeah, yes. So some kind we could have been written already automation test or some kind of regression suite using any functional testing tool. We will have to run all those things while developing with the UI. So we need to compare whether actual response is showing in the UI or not, or any discrepancies are there with the response coming from the server and the showing in the UI. So like that, we have to verify few things. Like we can consider that as integration testing.
Okay.
And the next thing is API testing done before front-end UI validation or simultaneously, where there are two testers in a Scrum team? So I hope I answered this question. And next is, why we do API testing? What is the significance of it? What advantages it provides so that we carry out API testing? So this is also we are going to cover in this session. So let's briefly explain this one. So what advantages it provides means, suppose we have built the system with the APIs. We are providing our service, exposing our functionalities with the APIs, and we did not tested those APIs, but we are directly using or directly developed the UI. So in that case, we may not know which kind of response is coming, or which kind of you know which is actually serving our purpose in the UI or not. We do not know whether our API is developed or serving the actual purpose as per the business requirement coming from the product. So in order to check and provide actual functionality or exposing functionality to the user, we need to test the APIs first before the development of UI. So we can I can explain all the complete details in the coming sessions about this.
So if the API testing is performed fast, that may result in a less buggy application, right? And
Obvious. That is obvious. So in each development life cycle, there will be a test according with the development happen. So in the requirement phase, we will be having some verification type of testing. And as soon as you write the code, there will be a unit test. As soon as you develop component, there will be integration. So like that, in every phase of development life cycle, there will be a testing phase will be there. So in that case, we are coming into the new type of architecture to build the APIs. So in that case, we have to do all these things parallelly: verification, unit test, and the integration. There is a API testing should be there to for a less buggy application before developing the UI, actual UI.
and also I saw something like this, like the testing team may sometimes in the company to company may be categorized as white box and black box.
Yeah,
So
yes,
yeah,
it depends. Yes, so
yeah,
whether the company needs its services to provide publicly over API or internal to their intranet, or it depends on the company whether they want to expose out or not. So
yeah.
depending on that
That
also, there will be API testing which is needed without the UI itself.
and the testers who generally perform this API testing will generally work very close with the developers, I saw.
Obvious, which is obvious because it is completely it's a kind of a white box testing. So there is no there will be a code interaction. We have to try to understand what actually code is doing. So it is far better to understand code, how it is actually going there, how we are making the request and how we are getting the response, how the serialization is happening between the client and server. So if you are able to understand those things, then we can do testing better of the APIs. So instead of UI is a kind of a black box test, so which can which we don't need what actually internally is happening, but we need to verify whether the UI is presenting the responses as per the client or not.
Okay.
I think so far so good, and we'll going to the other question. Are there any types of or categories of API testing? If yes, what are they? Yes, there are few types of API testing. Instead of saying the types, we can say the techniques.
Vishwak, we lost you.
Change few attributes, we need to do some mandatory field testing, and we need to do some boundary value analysis, or we need to do some kind of authentication related testing. So there are a few things that we will discuss in the coming sessions. And before starting API testing, what are the prerequisites we need? Yes, so before starting API testing, I think this will cover in the next session itself, but I will briefly explain. So before starting the API testing, we need to understand what is the client server architecture, how client acts and how server acts, and what is the application layer in between them, how the logic goes, and how the serialization of request and response happen. So the basic understanding, these things should be there. As well with, there will be a, so as soon as you start API testing means you do not directly get into the automation. So before that, we need a functional testing should be happen on the APIs. In order to do the functional testing, we should not have any other things like UI. So UI can be, you can see on the web itself, but In order to API testing, we need separate client, functional client tools. Those are like Postman or Swagger or some other tools, some other third-party tools. We need to, I mean, the knowledge of those tools is required to functionally test the APIs. So those are the prerequisites. And next is the difference between API and REST API. Yeah, this is I think it's fine. So application programming interface, as I explained already. So API can be anything, but REST API is the it's a type of API, whereas you can say SOAP API or you can say REST API or something else. So but the API is programming interface which provides the communication or interfacing between the two systems. So REST is a type, some other, no, it is a type of architecture. So in this we use some services to serve the same programming interface. In the SOAP API, we will be using some other technology to serve the API purposes. So this is a type of API. REST API is the type of API.
And what is the difference between this SOAP and REST APIs?
So SOAP basically uses other technologies to implement the API, whereas REST uses some other technologies to implement the API. That is the main difference.
Okay.
So we will get into the complete details of how it is differentiated from each other and how the differentiation is happened, why those two things are came into picture, when this was developed or when where this was developed. We will see all the details in the coming session.
Okay.
Can it be possible to do response comparison after migrating from ESB to web methods? I did not get what actually the ESB and web methods. Rizwan, I am learning your question. Can you please say about what actually the ESB you are referring to?
Hello, Vishwak.
Yeah.
Yes, Vishwak. Actually, we have implementation of ESB earlier. Okay, now we are migrated to web methods. Now I want to do comparison with, it's in production. So earlier the response of ESB, I want to compare. Yeah, now the implementation is in web methods. I want to compare the ESB's response with respect to the web methods implementation response. So can it consider any response? Can I do comparison using SOAP API tool or any other API testing tools?
So you could be using some tool while you are working with ESB, right?
Yes.
So and as well as with the web methods, what you will be using?
SOAP API.
So I'm trying to understand what actually ESB you mentioned here.
ESB is just an actually a kind of interface which it is converting from SOAP to REST services.
Oh, okay.
Yeah. So it's giving me the SOAP request response back. Okay.
Okay.
I want to compare now that actually ESB is supported by IBM. Now that we move to web methods instead of ESB, we move to web methods. But since with respect to ESB implementation is already in production, there are some issues coming out. So that response I want to compare with this web methods implementation. Also, I'm getting the response. Right? I want to just compare the response. That response is matching this web methods response or not.
Since it is specific to the IBM technologies, it's fine. I'll try to get the things up regarding this ESB and web methods, and I'll explain these things in the coming session.
Yeah. To ask in generic, just wanted to know, can we do a response comparison between?
Yeah. So you are able to converting from one response or one kind of response to the other response, means there will be SOAP UI may provide this kind of functionality to compare the responses. Otherwise, as soon as you take the response of REST API and you take the SOAP response, you can compare each other. You can compare each other directly. I hope SOAP UI will provide that kind of functionality, because SOAP UI, it is a it is a big thing which provides all kind of activities which are required for the APIs.
Okay, fine, perfect.
Okay, Vishwak, I think we are done with all the questions. I think we can wrap it up for today and can meet at the same time tomorrow and then continue.
Yeah, sure. Thanks everyone.
Thanks everyone. See you. Bye.